As developers take a bigger ownership in ensuring mobile application quality, they need the flexibility to work with the preferred frameworks and the ability to scale mobile test automation easily. SASctl mobile testing solution addresses this need by offering support for a broad range of test automation frameworks, including Appian, XCUI-Test, and Espresso. And in this demo video, we will showcase how mobile teams can use the Espresso test automation framework on the SASctl Real Device Cloud to scale and execute test suites on Android emulators and thousands of Android devices to maximize developer productivity and improve testing efficiency with comprehensive coverage and parallel testing. First, we will start with the sample Espresso test suite, which will test the SASctl demo app. The Espresso tests contain a full flow test class, which will walk through the application, a login test class that will test the login screen. The test classes will have one or multiple tests per class, and they will have annotations like happy and or error flow. To run your tests on SASctl, you need to create a build for the app to be tested. This can be done with, for example, the Gradle W assemble debug command. And you need to have the app that will hold the Espresso test cases. You can run that with, for example, Gradle W assemble Android test command. We've already created both apps and created a sample project that will be used to start running Espresso test cases on Android emulators and real devices in the SASctl cloud. To be able to run Espresso tests on SASctl, you need to use our SASctl Runner. SASctl is a highly configurable command line interface that will automatically push your app under test and app with the tests to SASctl, distribute and run your tests on Android emulators and on real devices, and report back the results of your tests. More information about how to install SASctl on your local machine or within your pipeline can be found in the description of this video. After you've installed SASctl on your local machine, you need to configure the project. SASctl can help you with that by running the SASctl Init command. This will help you create a YAML configuration file, which you can use to run your tests. By running the SASctl Init command, you will get a few questions. We first need to select the region. We want to run it on the EU data center, so it will be the EU region. Then we need to select the framework. We're going to run Espresso test cases, so we need to select Espresso. Then we need to select the application that needs to be tested. It can be found in the apps folder, and we need to select the first application. Then we need to select the application that holds the test cases. Again, this can be found in our apps folder, and we need to select the test application. Then we need to select a device, a real device. In our case, we're going to select the Google Pixel. You're seeing the dot asterisk here, which means that it will select an available device. Doesn't matter if it will be a Google Pixel 1, a 2, or an XL, based on dynamic allocation. Then, if we want to run our test cases on an Android emulator, we can select an emulator here. We're going to select the Google Pixel 3. Last but not least, we also need to select the platform version for that emulator. In our case, we're going to select 11. Then, if we want, we can also store the artifacts. And with the artifacts, we mean if you run test cases on SASctl, we store logs. Do you want to download those logs when the test case is done? In this case, we're going to select always. As you can see, the default configuration file has been stored in the .saslabs folder. If we would open the configuration file, then you would see all the selected options from the init command. We would like to refer you to the documentation if you want to alter specific things in this configuration file. When you're done with the configuration, you can run the Espresso test by running the SASctl run command. By default, it will search for the configuration file stored in the .sas folder. But if you want, you can provide a different configuration file through the command line. For now, we're going to run our Espresso test with the default configuration by entering the SASctl run command. SASctl will automatically upload the apps to the SASctl storage and run your test on the real device or emulator from the configuration file. If your app needs to use services that are behind the corporate firewall, you can use SASctl. How to set up SASctl tunnel can be found in our documentation. The link can be found in the description of this video. Once SASctl is running, you only need to provide a tunnel name in the YAML file to let Espresso use the internal services. When SASctl is done running your Espresso tests on SAS Labs, you will find the end status in your terminal as you can see here. You can also go to SAS Labs to view the logs and watch the video of the test execution. We configured SASctl to run our Espresso test on an Android emulator and an Android real device. Here you can see the last execution on an Android emulator, and when you click on the real device's radio button, you can see the last executions on real devices. When you would open the test execution on a real device, you would see all test cases from the 2 test classes we executed. You can also watch the test execution by playing the video. You can see the same for the Android emulator. When you go back to the test overview, select the virtual cloud and then open the last test execution, you would see the same test with the same test classes and test cases and a video. For the real devices and the Android emulator test execution, you can find the logs in the log tab. If you selected to store the assets in the SASctl configuration file, then all logs are stored on your local machine or in your pipeline. In our demo app, we use 2 test classes, a full flow test class with 1 test and a login test class with 5 tests. They were executed on only 1 emulator and 1 real device. You can maximize the usage of parallel testing by letting SASctl automatically shard the tests by providing the concurrency you need, providing a test option property with num shards is, for example, 4. SASctl will then automatically divide the tests over 4 instances and run them in parallel by providing a test options property together with the num shards property. When sharding is configured, SASctl automatically creates the sharded jobs for each of the devices defined for the suite based on the number of shards you specify. In our case, we're going to define 4 shards, and the test methods will be divided over 4 real devices and 4 emulators. The shards need to be added on the suite level. If we would now run our test case again, we would see that SASctl will divide our test cases over multiple instances. When SASctl is done running your Espresso tests on SAS Labs, you will find the end status in your terminal as you can see here. You can also go to SAS Labs to view the logs and watch the video of the test execution. As you can see here, SASctl used the test name and postfixed them with 1, 2, 3 or 4 out of 4 shards. When you would open one of the test executions, you would see that it didn't execute all tests in one session, but a subset of those tests. To understand more about how to run your Espresso tests at scale with SASctl, we advise you to check all possible options in our SASctl Espresso documentation. Happy testing!